Welcome back to the 2021 convention. This afternoon, the first thing we're going to do is give you a quick run through by way of a slideshow of the design work and other activity that's been taking place away from Darlington. We will follow that up with an update of the project plan and the anticipated finish date, which Terry Graham will take you through. And then after that, I will do a live walk around the engine with the video team following me so that you can see what's actually happened here at Darlington Locomotive Works. As we do not have the services of a Doncaster or Darlington Works of old at our disposal, a large amount of activity takes place away from our workshop. This presentation will provide an overview of this work over the last 12 months. As you'll be aware, we have two boilers under construction at Meiningen in Germany. The first one, seen here, is destined to go onto Tornado during its forthcoming overhaul this winter. The second one for the P2 is not far behind and should be delivered during the spring of next year. Meanwhile, the tender frames are making good progress at Ian Howitt's Crofton workshop. Work is presently concentrated on detail components. On the left in this photograph you can see some of the axle boxes which have been partially machined prior to welding on manganese steel liners, and on the right you will see various brake rods and brake stays which have been tacked together ready for coded welding. The left-hand view shows the brake cross shaft and the rubbing block which is attached to the front drag box. The right-hand picture illustrates the screw and nut for the handbrake handle. Meanwhile, Alan Parkin from his home at Ranby near Retford has made substantial progress with the pipework and electrical trunking, and is able to complete it now we know the shapes and positions of the ETCS cab signalling equipment which has to be fitted. One of the encouraging and gratifying things about the way in which this has been done is that from these 3D models, Alan produces individual drawings of pipework and trunks, which he then hands over to Ian Matthews in our workshop, who then makes up parts, and most of the time the whole thing just slots together like Lego. The biggest story this year has been the cylinder block. Its design has been completed and Alan has turned the model into a total of 62 production drawings. This is another example of a detailed drawing of the right-hand middle rear exhaust port bottom plate, located as shown on the underside view of the cylinder block. To assist potential builders to understand what is a complex fabrication, a 1/8 scale model has been built using 3D printed parts. The assembly of the model has been photographed and used in a PowerPoint presentation to suggest a logical order for assembly to ensure that all the joints can be welded. Additionally, Frewer Engineering were contracted to check the steam flow through the passages in the block using computational fluid dynamics, or CFD for short. Other than a couple of minor tweaks to round off sharp edges, this demonstrated that our design is well optimized. For the most part, the new cylinder block is a fully welded steel fabrication made of plate and tube. However, the steam ports that connect the steam chest to the valve chest were deemed too difficult to fabricate. There would be almost as much weld as parent metal, so castings have been chosen. Daniela Filova has converted the 3D models previously made as part of the original design into manufacturing drawings. As these are highly stressed items, from differential expansion rather than steam pressure, Daniela went on to carry out FEA, that's finite element stress analysis. This resulted in a few changes to reduce localized stresses, including incorporation of mid-feathers in the main tube. With the design complete and following a comprehensive supplier selection process, a contract was signed with Halco at Irvine in Scotland to fabricate and machine the cylinder block. Shortly after, an order was placed on William Cook Cast Products at Sheffield for the patterns and castings for the steam ports. The front middle steam port pattern is shown here. And by early September, all 6 steam ports had been cast. At Irvine, significant progress has been made on manufacture, including machining the middle cylinder front and back plates, welding the pre-machined middle cylinder to the front plate, and machining the first of the valve chest housings. As you will see, we have pattern equipment for the Class K exhaust steam injector body, kindly loaned by the 71,000 Duke of Gloucester Trust. However, we only have installation and parts drawings for the injector, so with the kind cooperation of Locomotive Services Limited at Crewe, we're able to borrow and fully dismantle the similar injector of 70,000 Britannia and reverse engineer it into an accurate 3D model. I produced the model for the body, whilst Martin Shepherd produced models for all the innards. Martin has been refining my original 3D model for the cam box and has also produced 3D models for the reverser drive mechanism from the cab. He has also been busy producing manufacturing drawings for the valve gear, and at 79 individual component drawings so far has made very considerable progress. Thanks to his previous professional experience, Martin has formed a relationship with the Warwick University WMG, Warwick Manufacturing Group, who have kindly printed 3D parts for a 1/3 scale model of the cam box, which is on display today. I will now hand you over to our electrical wizard Rob Morland, who will give you a quick canter through developments on the electrics for the P2.
So we've made good progress on the electrical system design and also putting together the documentation to support it. The circuit design is now essentially complete, and we've put together over 40 schematics. The design paperwork has all been produced, and this includes a full system specification document, a clause-by-clause assessment of the design against the applicable standards, and a hazard log which talks through all the electrical hazards and our mitigations to cover them. And all of this is currently under scrutiny by Graham Nicholas. So I thought I'd tell you a little bit about some of the interesting things that we've been doing during the year. One area that we've had to find a solution to is bulkhead light fittings. We need to find an alternative bulkhead fitting design, because the ones we used on Tornado, both types that we use on Tornado, are actually now obsolete and you can't buy them anymore. So we purchased a number of examples and evaluated them to see whether they'd survive on the P2. Unfortunately, few of them were robust enough, and some had glass fronts that really wouldn't last long in our environment. And after a lot of searching, we identified a time guard fitting, which has got a polycarbonate front, and it's available in 2 different sizes. And this actually passed our very scientific test of dropping a brick from 1 metre to test whether it will withstand impacts. Sadly, the paving slab actually underneath the fitting did not survive the impact test, but it certainly proved that the fitting will survive on the P2. So we've purchased a whole set of these, and Alan will be adding them on to the 3D CAD, so we know where they're all going to be positioned on the engine. We've also been doing some work to improve the way in which the sanders operate on the P2. We need them to start reliably, but then we don't really want to use quite as much sand as the ones on the A1 use. So we've devised a circuit which has got a choke in the air supply. And this allows us to give a high pressure burst of air to start with to get the sand going, and then to reduce the pressure so that we reduce the amount of sand we use during the actual sanding operation. We've built and bench tested the circuit to do this, and we now need to test it with some real air and real sand. Another area which we've been spending some time on is interfacing the turbogen to the rest of our electrical system, and we want to improve on the way that this happens for the P2. So on the P2 there'll be two turbogens, and it won't necessarily be obvious to the crew when one of them is running and the other one perhaps is not running properly. So we've designed a tachometer circuit which will detect when the turbine is up to speed, and then it'll connect that turbine to the electrical loads automatically without the crew needing to worry about it. And we've prototyped this circuit. You'll see that we've made use of a suitable available container and tested it on Tornado, and it seems to work fine on the turbogen on Tornado. So we'll now add that to the system to be designed and built for the P2. So what are our future plans? Well, probably the most significant activity going on at the moment is actually the ETCS program. This is the European Train Control System, new digital signalling system, where there's a project in partnership with Network Rail, Thales and SNC-Lavalin to fit ETCS to 3 heritage locomotives, and these are the A1, a Black 5 and one of the preserved Deltics. So this at the moment is a focus for us because the design of the tender for the P2 is going to be very similar to the A1 tender once it has ETCS fitted. So we paused the design of the P2 tender pending the project moving forward. But that's now going really well, and as soon as it's sufficiently progressed, we'll be able to complete the P2 tender design, and then everything will be finished and ready to go. Work will then start on building and testing all of the main electrical systems, and as with Tornado, these are designed to be assembled and tested off-site in my workshop down in Cambridge, and this makes installation very simple, and the final testing at DLW is then pretty straightforward, and hopefully you'll see some more of our kit on the engine by the time we meet next year. So that's all from me. Back to David.
Thank you, Rob, for a concise update on our seriously complicated electrical system. Now I'll hand you over to Terry Graham, who is our project manager. Terry is a man of many talents, as you will see in this picture here. He's also quite good at polishing things.
Good afternoon. I'm going to talk you through our project planning. We'll look at the progress we've made over the last year, all thanks to the generosity of our supporters. Then we'll look forwards to what will be happening in the next 12 months. This is a very complex project, but the driving force are the donations from our supporters. We run a 900-line project plan, and our cash flow dictates our pace, and it's a balancing act to progress as quickly as our income allows. In summary, we're about 65% complete and plan to complete the build in late 2023, after which a period of test and trial starts. There are many pressures on us that we must navigate our way through, and COVID has been one of them. It's caused delays to delivery dates and has affected what we can do, but we maintain our momentum as much as possible. This year we have seen material costs rise significantly, as well as labour rates and increases in lead times. Also, COVID has affected our ability to raise funds. We plan around an income prediction and replan as necessary. It's a difficult balancing act. Our completion date has slipped from the end of 2022, but the big ticket items are mostly delivered or ordered. Design work continues on the valve gear and the details for the cab and tender pipework, as well as the electrical trunking. The electrical side has been held up waiting for a decision on the ETCS system, which is currently being taken, so we can now move forward with this area. We've made good progress this year on installation of equipment between the frames that would be difficult to access once the boiler and cylinder block are fitted. The air pipework between the frames is now substantially complete, and the steam and water pipework is delivered, and we've recently taken delivery of the bronze bar which we'll need to manufacture the unique fittings for this pipework. The brake gear is assembled and the coupling rods delivered, polished and bushed. The cylinder block design has been completed, a supply selected and the order placed. The axle driven alternator, ADA, and its test rig have been built and testing is underway, which is a critical part for the electrical system. Looking forward to the next 12 months, big ticket items such as a boiler and cylinder block will be delivered in mid-2022, and we must complete the pipework and fittings before their installation. The tender frame will be delivered early next year. Then we need to make and fit the pipework and trunking, balance, then install the wheel sets and fit the tank. Some of the heavy motion has just been fitted. We need to finish this off and check its operation with powered rollers. We've made good progress on the design of the valve gear and now need to manufacture and test the critical areas on a test rig, as well as look into the reverser mechanism. So in summary, we've achieved a lot in the last 12 months, but there's plenty more to do, but with your support we can get there.